This is pre-calc notes on 3.4, reflections, vertical stretches, and compressions. Okay, so for all three of those different types of transformations, reflections, vertical stretches, and compressions, we're all worrying about the A term that is happening in front of the parent graph, or being multiplied to the parent graph. And we're going to start out, if A is negative, it is a reflection across the x-axis. Now, you should already know this from last year in your Algebra 2 class. And again, we're starting with a parabola, which is something that you already learned how to work with and do transformations on. So here I'm just reflecting the parabola across the x-axis. Before I switch this screen, let me just point out that we're learning a brand new transformation. Okay, this one is different, the one I'm making in blue. This would be what would happen if that negative is happening before we apply the parent function, or inside parentheses. And that would reflect about the y-axis. We're going to see an example of that in the next slide. Okay, here we go. Here we've got a reflection about the y-axis because we are applying the negative to the x before we raise it to the power of 2. Now, this is a little bit, just a little bit funny. For example, the point 1, 1, when I reflect that across the y-axis, it ends up on negative 1, 1, which is already a point on the graph. And the point 2, 4, reflected across the y-axis, ends up on negative 2, 4, etc., etc. So the graph of the parent graph, which is y equals x squared, and this graph, in this case, happen to be the exact same graph. And that makes sense algebraically, too, because if I were to simplify this expression, any negative raised to an even power becomes positive. And so algebraically, they're the same as well. Next slide. Okay, now I've got a linear graph, okay? And so here I've got a negative that is not inside parentheses, so this is being reflected across the x-axis. So let's think about the point 1, 1, reflected across the x-axis goes to 1, negative 1. And maybe, okay, and how about 4, 4 goes to 4, negative 4. And how about the point negative 8, negative 8 goes to negative 8, positive 8. Okay. So here is that reflection. All right, am I done? I think that I am done. No, I'm not. Reflections, vertical stretches, and compressions. All right, going on to compressions and stretches. So if I have an A that is being multiplied outside the parentheses for the parent function, it is going to be either a stretch or a compress, okay? If that number that I'm multiplying by, I said A, but we're calling it C for these problems. If that number is larger than 1, then it stretches away from the x-axis. For example, G equals 2 times the absolute value of x. So if I were to take the point 1, 1 and multiply it by 2, it goes here. If I were to take the point 4, 4 and multiply it by 2, it goes to 4, 8, 5, 6, 7, 8. So it goes here. And I'm going to do the reflections too. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here. Okay, so a stretch gets taller and skinnier. It moves away from the x-axis. Okay, and that's what this says, away from the x-axis. A compression is what happens when you're multiplying by a number less than 1. So I'm going to do the bottom one now. So if I were to multiply, let me go to the point 2, 2, and just take half of that number, it comes down 1. Okay? If I were to take 4, 4, take half of 4, the y coordinate is 2, it's coming down 1. And if I were to take the point 6 and then divide by 2, it is coming there, right? So here is the graph of the absolute value multiplied by a number less than 1. It is compressing closer to the x-axis if that number you're multiplying by is less than 1. Okay. Now this is, you did the vertical stretches last year in Algebra 2. This is brand new. Okay. This is horizontal stretches and compressions, and it's the same concept, except here you're multiplying that number inside the parent function or inside the parentheses before you do the parent function. So here I've got this 3 that's going to be multiplied before I take the cubic root. So that is going to be a compression towards the y-axis. Okay. All right, let's see. So that means, hold on. I've already got these actually shown out in the graphing calculator very specifically, so you don't have to deal with my bad handwriting when you look at these. So this one, let's just say this, is going to be closer to the y-axis than the parent function that you see, okay? This one is going to stretch away from the y-axis, okay, because I'm multiplying a number less than 1 inside the cubic root before I take the cubic root. Okay, so I'm going to show you the calculator screens on these. All right, so here what I've got, I want you to pay attention to the table. Okay, here what I've got is in this column I have the cubic root, and in this column I have, first I multiply by 3, and then I take the cubic root. So each of these points is getting a little bit taller. So instead of 1, 1, I have 1, 1.4. So it's a little bit above that point on the parent function. 1.8, it was 1.2, and then it becomes 1.8. So it's a little bit above that point on the parent function. It was 1.4, now it's 2.1. So it's, again, above that parent function. So this is getting closer, it's compressing closer to the y-axis, okay? It's still the same shape, but it is now closer to the y-axis. Now we're going to look at the one where it's a fraction inside that radical, okay? And notice that these numbers, here is the cubic root, just the parent function. Here is the multiply by 1/3 before I take the cubic root. And you notice that 1 goes to 0.7, 1.3 goes to 0.87. So they're getting smaller, all right? So instead of at 1, 1, I'm now here, and it's very tough to graph these, but they're all less than the parent function. So this is a stretch away from the y-axis. Okay. So there you go. Horizontal compressions are a little bit harder than the vertical stretches and compressions, but you have to have a vague idea of what it means to be stretched or compressed against both axes. All right, that's it.